That's how everyone else does
Wait,
it.
I need
You
to
have to
practice. I need to write.
Most companies you work for, most companies you'll find, not most,
Yeah.
but a lot of companies you'll find, yeah, online. A lot of companies you'll find, you are the technology person. So if you get a job, say right now, if I got a job, a company hired me in C#.
You're gonna cut what they say?
Alright, so say you got a job in C#, right?
Okay.
From a company I'll be the technology expert, right? Small company, mid-size, say 100, 200, 300 employees, okay? And I'm the technology expert, the programmer. I can take the job right now. Why? Because while I'm taking what they need down, I can learn enough C# to play around and do things. Yet, most jobs, you're going to have to bluff your way into it. That's just the way it works in the world. It's not a bad thing. As long as you're beneficial to the company, that's the way you got to do it. I did that throughout. More time?
How did you start from where? How did you start?
I give you an example. Say I remember one time I worked for the city of New York. Okay, so they said, you know SQL? I said yes, I do. They said okay, they don't know anything about it. Okay, we're trusting you. This and they tell us what needs to be done. While I was doing so, I'm taking down what they need to do. I'm looking up and I get advice, ask my friends. Come to me anytime. Any questions? You know what I mean?
No, I know.
So you bluff your way for the first few months, but they don't know the difference. You are the expert, and eventually you do know your stuff, and you do it for the next job you get as you build up. Always take on things they don't know enough. Everyone does it. It's the only way to.
No.
What's the worst that can happen?
No.
What's the worst that can happen? Okay, so let's get going. So chapter 13, I think. Let me just check over here. Chapter 13, you'll finish the beatbox machine.
Okay.
Here's 11. It starts. 12 and 13. Throughout these few chapters, you're building a MIDI device. I'm not going to go through the MIDI device because that's not needed for standard Java programming.
So it's the GUI stuff when I'm going to...
The GUI stuff we'll learn, but we're not going to learn specifically how to build this MIDI thing. That if you want to learn, you can look up the book. Because it's just you have to learn so much for the MIDI stuff that it's irrelevant for your career unless you are building a MIDI device for your company. But that's a very unique job.
I know, at least what I like.
Let's go ahead, yeah. It's
I'm not going to
amazing.
go into it right now. It's something I'm going to do it when I'm going to have time. I don't have time to learn.
For sure. If you want to, you can. Best thing to do is just get the code, look through the code, and a lot of this code I didn't write. You think I wrote all this code? I didn't. Some of it did, some of it didn't. Some of it's just downloaded from the book site.
What do you mean? How can I know what to write?
Look. So let's go back. Let's go to chapter 11. Okay, exception handling. Okay, this and the next chapter, actually, and chapter 13, explain a lot how MIDI in Java works.
Mm-hmm.
It's not essential, so no notes will be here, but look there if you're interested. Okay, so what's an exception? Exception means, for example, say I have a program that pulls in a file from the directory, right? Now, there's many reasons why a file might not be there. It could be a person forgot to put it there. The person took it away. It was deleted. It was moved. I don't have access to it, right? So since your program is depending on an event that you have no control over, you basically can tell your code, listen, be careful. You're about to do something that is a lot of things can go wrong. So how are you going to handle that? That's called an exception. An exception is, we'll see later on, there's different types of exception, but in general, exception is, most of the time you won't write them. I mean, you'll write some of them throughout your career. Most of the times you'll be dealing with the ones that Java already gives you. For example, if you're trying to pull in the file, you have to have a way to handle that. Are you going to say, if the file's not there, should your program just blow up? I mean, you obviously want to deal with it. Okay? So, you can notice that if you look over here, let's see over here, open one of the codes for chapter 11. And this is, I want to do all the complicated stuff here, so we're just going to go through some of the basic stuff here. So you see over here.
This is the code from the book?
This is from the book, yeah. So ignore everything else except for this. You see I have try, right? And then I do this. Okay?
Okay.
Get sequencer. This get sequencer throws is very dangerous. Because, not dangerous. It's not 100% guaranteed it's going to work, because sometimes a device doesn't have a MIDI sequencer. For example, if there's Java installed, say like on a popcorn machine, you're not going to have a MIDI sequencer in there, so this can fail.
Yeah.
Okay. So you do try this, and over here you catch it. Okay, and this is what's caught. You catch the exception, and over here we're just doing a print stack trace. That prints out like what happened, what was the error, what happened. This is one way to deal with it. This one, obviously, if this doesn't work, we're going to get a big fail. Okay, let's go to another one. And you have to, for classes and methods that have an exception, you have to handle it. You can't not do this. You have to do that. Let's go for, and there's not that many. You'll get it like when you're trying to connect to, say the internet. If you're trying to connect to a database, there's different things where you're not in control of those systems. So you have to, basically tell your code how you're going to deal with it not being up. Okay, so that's called a try-catch block. So we hear try catch.
Yeah.
A try-catch block tells the computer that an exceptional thing could happen in the method you're calling, and that you're prepared to handle it. The compiler doesn't care how you handle it; it only cares that you are going to hear it. As long as you acknowledge, I'm going to handle this. Okay, an exception. In other words, what this thing is throwing at you, throwing an exception. The exception actually is an object, so you can find out information on the exception.
Yeah.
Okay. You'll spend much more time of your Java coding time handling exceptions than you'll be spending creating and throwing them. Okay, so most code that has exceptions is not because you created them, because you have to run them and you have to deal with it, like opening a file, etc. Okay. Okay, so let's look at an example over here. Here's a throwing example. So here's a public void, take risk. And over here it throws a thing called a bad exception. We'll see later on how you create these. Okay? And what does this take risk do? Say in the code it does something, and if this happens to be true, boom, it throws this bad exception.
Okay.
So now when I'm calling this, when I'm calling this method, so look, over here, since I'm over here doing take risk, I have to do try and catch.
Throw is an object.
Can you hear you?
Throw is like an.
It throws an object, so we're getting back a bad exception object. Okay? So notice over here, look what's happening. We're trying to take this risk, and we catch, if this bad exception is thrown at us, we'll print out R and EX that prints extra. So notice, what is EX? EX is the bad exception itself. That's what was getting thrown at us. That EX we're printing out the print sectors.
Okay.
Okay, so you should look over this piece. This piece is very important. Basically, this is how you'll deal with exception handling.
Mm-hmm.
So say if you are connecting to a database and it returns an error exception that says database is not up.
Yeah.
So you can return back to the user, database is not up, come back in a half hour.
Okay.
Okay.
Okay. Try.
Okay. Now, here is actually the actual a clip, a little snippet of the Java hierarchy for exception. Exception is the top class.
Mm-hmm.
Under it, you have IO exception, IO exception. There's a little more. There's more than this. Notice that runtime exceptions is in gray.
Yeah.
Runtime exceptions are exceptions that you do not have to try and catch. If you want to, you can, but if you don't want to, it's fine. And if you happen to get while you're running your code, okay, your code will blow up. Okay. An example is, imagine you're parsing an integer. Right? Remember we looked at a couple classes, last class we learned it? Let's say you have 2 in quotes, and you want to convert that to 2 an integer.
Okay.
So, I'll show you right over here.
Yeah, I know. Person. Yeah.
Let's see.
When you want to pass integer to string to an integer, no?
Yeah, I don't think I have it here. But yeah, so if you parse an integer, right, which means you're converting it, right? So what happens if if in that 2 it says 2xz? You'll get an exception. You get an error. That's an exception. So we see over there that there are some exceptions that you don't have to do a try catch. Like try converting it. If not, say to the user, enter something else, right? You don't have to do that. You could if you want. You don't have to. And what's the reason for that? The reason is that runtime exceptions are exceptions that you shouldn't be getting in the first place. You should not be. Your code should be well enough built that it should not be possible for you to be parsing a 2. You know what I mean? You should be checking and guaranteeing that it's a 2 before it even gets to that point. The exceptions that we're handling, that you must handle, are exceptions that you cannot control. You created your program. You cannot force someone to always put a file there. So you have to do a try-catch situation where you try to see if it's there, and not then you handle it some way. Okay. Okay. So here's some of the examples of runtime exceptions. We have divide by 0. Say you're in math and you divide 9 by 0. That's impossible. So you get this exception.
Okay.
But you don't have to. You don't have to try and catch it. You can just make sure your code doesn't ever do that.
Yeah, but if someone user doing something wrong.
But it shouldn't be. Your user, say your user enters in something that says 0, and you want it divided by 0.
Yes.
Your code should not even pass it to a division thing if that's the situation.
Okay.
You know what I mean? In other words, it shouldn't be at this point in your code where it's breaking. It should be that way beforehand. You're saying, listen, you passed a 0. Sorry, give me something else because this is not going to work. Here we go. Most runtime exceptions come from a problem in your code logic, rather than a condition that fails at runtime in ways that you cannot predict or prevent. Okay, so basically the end of the story is we do not runtime exceptions you don't have to try and catch, but every other type of exception you have to try and catch. You have to put in there try and catch.
In every code you actually do that?
If that method returns an exception.
I didn't know. Okay. So if they are.
If you don't, the compiler will tell you. Don't worry.
Okay.
I'll give you an example that we've used before. I probably don't remember.
Like a god.
Let's see where was our game? Leaders.
6.
Okay, so here's the leader game. What's an example? I thought we had examples sometime. Anyways, whatever. The point is this is if the more you deal with outside systems. Now a lot of this is not mine.
Yeah, but you wrote a lot.
Okay, but in short, this try and catch.
Yeah.
You'll need to do it if the method turns exception.
Yeah.
You won't compile. I'll tell you.
Yeah.
Okay, so watch this. See, this is how it works. You see over here, we have a thing that's we're trying this X dot do risky thing,
Okay.
and this returns an exception. Okay, so if it doesn't return an exception, okay, it goes to the next line, and after that, it skips over the catch because it didn't have to catch anything and goes to here. Okay, you made it. If it fails over here, well, it's not going to go to here. It's going to jump straight to the catch.
And then you send it.
And then it goes after. Okay? So the point is that when you hit an exception, it skips whatever's next and jumps right to the catch. And then there's a thing called finally. Finally means no matter what, if you go through try or go through catch, but the end go to finally. Both of them will, after they're done, will go to here.
So finally is the list. Okay.
Okay, so for example, here's an example. Say, turn on oven, right?
Yeah.
So say you have a thing to turn on and bake. What happens if it says, the oven's not working properly now. Well, you want to turn it off no matter what. So you can put turn off over here, which will run after this, or turn off that'll run after this.
Yeah.
Okay?
Yeah.
Okay. A method.
Try, catch, and find them. This is all chapter 11?
I think that's basically it, yeah. Yeah. That's basically it. I could be wrong, though. We'll see when we get to the end. So a try or catch block has a return statement. Okay? I mean, if it has a return statement, the finally will still run. Even if there's like a method that's returning something, and you do return over here, it'll still do this afterwards. Okay. A method can throw multiple exceptions. Many. Okay?
Mm-hmm.
And the cool thing is that since exceptions are objects, they can be polymorphic. In other words, you can get a parent class and therefore not deal with the lower classes. Like we said before. Every exception comes from exception.
Yeah, from a parent side, then you can use
Right.
that with everything else.
So here's an example. Okay, here's an example. So you see over here, here's exception, here's this, here's clothing exception that was created, and here's, say you're doing laundry, and here's a pants exception. You can't do pants in there. Here's a lingerie, shirt. And in the shirt, there's two ones: there's a t-shirt exception, a dress shirt exception, right? Look over here. So say I do laundry. Okay, I can catch a t-shirt, right? And I can catch the lingerie. And if I want, after that, I can just catch all the rest in clothing, because all these other ones come from clothing anyways.
So catches mean like the error, the fail?
I want to catch that error. So say I was trying to do laundry and it turned out that it was a pants exception. Well, this won't catch it because this is for t-shirts. This won't catch it because it's for lingerie. This will catch it because it's for clothing, and pants comes from clothing.
So it could catch it.
Yeah.
Okay.
You have to catch it somehow, otherwise it won't work. It won't compile. But the point is the buckets are smaller to bigger. In other words, this catches all of this, right? This catches all of this. So I can't put over here, I can't put, clothing exception over here and then try to catch a t-shirt. Doesn't work. This is a bigger basket, this will catch it first. Now notice, if you wanted to in all of your code, you can just say catch exceptions, and it'll catch every single exception.
Why I need to catch those stuff? Like, why I need to catch a shirt? Why I need to catch...
What if you want to handle differently? Say the handle was, your code does do laundry, and if there happens to be a t-shirt in there, throw that t-shirt into a special t-shirt bin.
okay. This is the catch.
Right. So say you get a general process, but if this happens to get wound up, you want to act differently if it was a t-shirt
Try
or for
something
lingerie.
and catch him and do something.
Yeah. So this person over here, his machine will be able to handle t-shirts exceptions differently, lingerie exceptions differently, and then all the other exceptions will be handled the same way. Okay? Now you won't be, exceptions are, you'll see, it's not that much in your code, but it's used when you're connecting to something and doing something that you cannot guarantee. Okay? Okay, so remember, the mother of all is exceptions. If you want to, you can just go catch exception over here, and that'd be it. But you're not going to be able to handle unique things, which is always the same. You can just, some companies, while you're building code, in the beginning, you can just write catch all exceptions and just print a stack trace while you're developing. In case that error comes up, then you start spreading it out and making it more fine-tuned.
So it's not good way.
Now, not in general, it's not good, unless you really don't care what the error is. Okay, last thing is, and this is also pretty weird, is that what if you don't want to handle it? You have to, but what if you don't want to?
Yeah.
You can actually just throw it yourself. You can say, listen, here's an example. Public void foo does do laundry. Do laundry returns exception, right? I can say myself, listen, I'm throwing an exception too. Whatever he throws at me, I'm just going to throw it to whoever calls me.
Why?
Say you don't want to handle it now. Say
So who's going to handle it?
whoever calls this. So you're asking a question, what happens if main, the one you actually run the program, throws it to? What do? So then it'll just blow up. It'll just shut down.
All the lazy programmers.
Yeah. So if you're lazy to do this, the person who runs the program at the end, it'll just fail. Okay? But sometimes your code, I can't think of the reason why you do this, but sometimes in your code you want to push it back. say you have a program catcher that catches all your database exceptions. So you can just throw all the errors back to him, and he'll know how to deal with it. But realistically, I can't even think of my bet really when you actually do this. Okay, so ducking only delays the inevitable. Sooner or later, somebody has to deal with it.
Okay, what?
Ducking. This is called ducking it. You're throwing it to someone behind you. Remember throwing a ball? You duck. Just keeps on going.
Oh, okay.
Okay? So if main ducks the exception as well, remember main is the one that actually gets launched when you run a program. If it ducks it and the exception is thrown, the JVM will just shut down. It can't do anything. You threw a object at it at the virtual machine, but it wasn't like it doesn't do anything. Okay? So here are some basic rules that you should know. And just throw them all in there. When you're doing a exceptions, do try and catch and finally. Or you don't always need finally, but always do try and catch. But if you want to do this stuff, here's some of the rules. You can't have a catch or finally without a try. Try is always needed. Between try and catch, nothing can go. So for example, over here, you have try and there's catch. You can't put code in between over here. You have the try section and you have the catch section that comes after here.
Yeah.
You can't.
Like if and else.
Yeah, you can't think of in between. Okay. Okay, that is one of those small things you're moving. I can do that. Really. That's really it. That's chapter 11. So that's basically how they handle exceptions.
Okay.
Okay. For review this, I remember I really enjoyed code. I'm not like
What?
I'm not like there's not really homework, but you really have to start writing code. It's the most important part. Mucho importante.